Financial statement analysis. I think the way the calculation is, when we do it face to face, so we are come to do time value of money. Now, when we talk of time value of money, we are simply saying that the worth of an amount today is higher than its worth tomorrow. Simply, if you have 1,000 cedis, the number of cement you can buy with it today, all other things being held constant, with more than the number of cement you can buy tomorrow. Okay, so in my example, I'm giving an example with an egg. Fried egg used to be 1 cedi for a long time in Ghana, but recently prices of egg has gone high, and now egg is, in my lecture notes I've written 1.5, but egg is now, fried egg is now 3 cedis. So if you have 1 cedi then the 1 cedi was more valuable because it could buy a fried egg. Right now, 1 cedi cannot buy a fried egg. Now let's say because of inflation, so 1 cedi can no more buy fried egg. Now let's even put the issue of inflation aside and look at interest. Interest has inflation, it takes care of inflation. But we are saying that if you have 1 cedi today and you refuse, if you have 1 cedi today, you could have what? Invested it, and you would have gotten what? Your 1 cedi plus the interest that will be charged. So I think that we are still saying the value of 1 cedi is worth more than today, because, again, example here, you could have invested the 1 cedi, and even if you didn't feel like buying egg, you could have invested this 1 cedi, and let's say the interest rate is 20%. So that in future you would have been better off. You have been better off. The value of your money would have increased to 20 pesos. So that is the ideology behind time value of money, meaning that as time passes, the value of an amount depreciates. Okay, all right. Now we'll be learning a lot of things under time value of money. We'll be learning future value. We'll be learning present value. We'll be learning annuity. We'll be learning perpetuity. We'll be learning constant cash flows. We'll be learning I've forgotten this amortization. Okay, all under time value of money. So now let's start. Future value. Future value is when you want to determine the current value. Sorry, future value is when you want to determine the, I'm repeating, determine, like if you have a current amount and you want to determine its value in future, right? In future. So you have money now. You want to determine its value in future. Why? Because if you have invested it, you have gotten interest, and in future you have gotten something in. So assessing the future value of a current amount. I'm trying to get an alternative, but let me see my lecture later using I'm still using future. So you are determining the value of an amount based on what? A future date. Okay, so let's see. This is the formula for future value. This is the formula for future value. Future value, this FV is representing future value. PV is representing present value. So future value is equal to present value times what? The compound formula, right? Compound rate. So we have 1 plus R raised to the power T. So to determine the future value of an amount, you have to compound it. Compound the present value, right? So we are compounding the present value. All right. I think the solution of this thing, this is an instant. I said, have 500 Ghana cedis, and you are trying to invest it at a bank that is ready to pay 10% interest per year for 5 years. You want to know the amount you will earn at the end of the 5 years. Okay, so meaning you are calculating future value. You have been given what? A current amount. You have 500 Ghana cedis. You want to invest this amount, hoping to get something in, and they've been giving what? An interest. You are trying to invest this money for 5 years, but the interest given is the annual. You are going to use compounding what? From the future formula to solve it. It is solved here. Oh, this is a different question. Okay, this is a different question. Okay, so let me solve this one. And this will, after understanding it. So let me just get my write-up. I like using red because it's easy to. Okay, I'll go for this. Right. Let me go for this. Okay, so there's the formula, right? Now let's this too deep. Let me reduce it to this one. Okay. Okay, so let's identify the necessary information we need. So we have what? Future value. From the formula, we have FV, which we don't know. So that one is not given. So that is what? Question mark. All right, then we have what? We have the present value, the PV. The PV is what? Identifying the information is halfway of solving your question. All right, so that is what? 500. Okay, then we have what? This one is a constant figure. We have R, the rate. Rate. And I will say rate of return or interest. That is 10%, right? And we know that 10% is equivalent to the same as what? Decimal form is what? 0.1. Okay. What again do we need? We need T. All right, so time. You are saving for what? 5 years. Okay. All right, 5 years. Okay, so now let's just insert them into the formula. Future value is equals to present value one plus R. Oh, this my R is big. Raise the power what? C. Okay, so we don't know future value, so we are trying to find the future value. Don't know what I should bring this, but okay, future value is equals to present value is what? 500. We have 1. The rate is what? 0.1. Okay. Then we have the time. T is what? 5 years. So raise the power what? 5. All right, so we continue. So this will be what? 500. Always you solve bracket first. 500 times what? 1.1. This point is suspicious. Okay, where's the eraser? All right, so point raise the power 5. So the next step will be 500 . Okay, so let's see. 1 raised the power 1. Where's my calculator? 1.1. 1.1 raised the power 5 is giving us, okay, I'll leave it at 4 decimal place. We have 5 decimal place. 1.615. Bracket going. Okay, this my sense is not all that attractive, but so that is 1.1 raised to the power 5. Then what will be the final answer? So what will be the future value? That will be what? 500 times 1.6105, which will give us what? 805.25. So that will be the answer. So this is the future value, and indeed, the future value is more than what? The present value. So, meaning the future amount is worth more than the present amount. Okay? All right, so that is future value. I think we have another question here. This one is solved, and I believe you understood the first one. Okay? So this one, to you are supposed to deposited 1,000 Ghana cedi in a bank that paid 5%. Yeah. How much will you have at the end of the year? This one has a certificate. So you got the formula, you set your present value here, your constant 1 plus 5% is what? Converting it to decimal is what? 0.05. Are we okay? Now, so that is it. So you, since it's raised the power 1, I think you don't need to bring it. That's why it's not there. Then to raise the power 1 is to give it anything raise the power 1 is same, multiply, and this is it. So after a year, the 1,000 is now 1,050 Ghana cedi. Okay. So quickly, let's go to present value. Present value is determining the current value of a future amount. So if I promise to give you 500 Ghana cedi in a year's time, you would like to take the current interest rate, probably the treasury bill rate, take that into consideration to what? Discount it to what? The present value. Because you might think you can use 500 Ghana to buy, let's say a cement is 100 cedis. So you might think to buy 5 cement out of it, and at the end of the day, by the time the year ends and you come for the money, you will probably buy 4 or 3, right? So as a finance person, when they promise you money, you should know that the money is not worth the value now. So determine the what? The current value of a future amount. That is what? Present value. And that's the formula. This one is change of subject from the Future value is calculated. So now we just made the present value what? The subject. And this is the discounting from. Discounting from there is 1 over this, right? The discounting factor. Okay. So we are discounting. So this is the same as this times future value. And if we just ended up this simplifying it like this. Okay. So I think there's a question here. This question says, for instance, if you have an investment that promised to pay you 700 in 2 years at a rate of 15%, then you can calculate the present value of the amount. So this amount 700 is an investment. The investment will pay 700, but will they be able to achieve the same thing that 700 now can achieve? So we want to know the present value. All right. So let's identify the information. We have the future value, in this question that was 700 Ghana cedi. Okay. All right. We have the time. T. T is what? 2 years. So that is the time, right? 2 years. All right. Then what again? We have the rate. The rate is what? 15%. Which I said in calculating, we do what? We convert it to what? We convert it to decimal. So that would be what? 0.15. Are you okay? So the only thing we don't have here is what? EB. And the present value which we are going to find out. Okay, so let me come here. I think I have enough space here, so I'll prepare this. Right, present value is equal to what? Is equal to future value over 1 plus raise the power t. Okay, so let's insert the information into them. The future value is what? 700. Okay. All over. We have 1 plus the rate is what? The rate is 15%. That's 0.15. Okay, raise the power t. T is what? 2 years. All right. So meaning that would be what? 700 over 1.15. Raise the power what? 2. Okay. So let's continue. And let's come and continue here, right? Listen. All right, so we have 700. There's a 700 all over 1.15 raised to the power 2. 1.15 raised to the power 2 will give us what? This one is in 4 decimal place, but I told you I leave my decimals at 4 decimal place until the final answer. As long as I'm doing the equation, I prefer 4 decimal place. I've done this since S. All right, so it is equals to, I don't know, one math teacher advised us on it, and that's it. Divided by 1.3225, we are getting what? 5, 2, 9 point. One is only 10. So this is the one that obviously you are jubilating that the half survived, the half survived. And after the time they are promising you, this is the value, right? Based on the interest rates, and they are promising to give you the value in 2 years, and so this is the value. And so that is time value of money. And as time goes on, the value of the money. So this 700 is what the same as this now. Okay, now let's continue. All right, I believe you understand it. We are going to annuity. What is annuity? Annuity is a series of equal payments that are made in what? In regular interval for a specified period. But so qualities of annuity, it should be equal amounts, right? Qualities of annuity, they should be what? Equal amounts. Equal what? Amounts. Don't mind my aim. Equal what? Amount or equal payment. There should be equal interval. If it's 1 year, every year, equal what? Interval. And equal what? Interval. And I don't know why I'm writing this in it. I will just anyway. All right. So there should be what? Equal interval. Equal. How do you write it? Is this woman is the same as equal what? Interval. Qualities of an element, there should be a specified number of if there's no specified, it's becoming a different. I don't want to mention it, so get there. Then there should be what? A specified what? Number of what? Period. So if you are going to pay the money for 2 years, you say 2 years. 5 years, you say you are going to pay for 5 years. Okay, so that it should be what? A specified number of period. Number. Let me use this shortcut of number. Yeah. Number of. That's the quality of what I need. And this three. So you have to get these three qualities to make it what? Annuity. Are we okay? Now let's move on. Now we have ordinary annuity and we have what? Annuity due, right? When we talk of ordinary annuity, we are talking of payment, an equal payment made at a regular interval or made at consisting of what? A series of equal payments made at the end of the year. So, and when we talk of annuity due, we are also talking of equal amounts for equal payments made at equal interval for a specified period. But this payment is made at the beginning of each period. So if it's yearly, if the period year is yearly, then annuity, under annuity, what we call deferred annuity, is going to make the payment on 31st December. 31st December, right? 31st December. But if it's annuity due, there's going to be 1st January. Please note the difference between ordinary annuity and annuity due is an ordinary annuity that is equal amount that is made at equal interval is made at the end of the period monthly. Then this payment is going to be, if it's January, then it's going to be the 31st January, right? That is, like, annuity due will pay on 1st January, right? Okay. The same way, if it's going to, if it's February, then annuity, ordinary annuity payment at the end of 31st, annuity is going to be at what? 1st February. Are we okay? Yeah, so we are moving on. Okay. Now, another thing we should know is that annuity, we have future value annuity, we have present value annuity. So when they give you future payment, and they say that, oh, from next year, when you start giving you a small amount of payment for this amount of specified amount for a specified period, then can determine what present value of those amounts. So that is present value. And if they tell you that, oh, have current amount that is being given to you, series of amount that is being given to you, and they are telling you that they're giving this amount for 5 years. So go ahead and the 5 years, go to the example. That is telling the future value of this amount. Okay. Now, this is what you have annuity and present annuity are going to be affected. It can be annuity due, can be that is payment at the end of the period, or it can be annuity what? Okay, sorry. It can be other annuity, which is payment at the end of the period, or annuity due, which is payment at the beginning. So let's assess this thing. Now we have ordinary future annuity. Ordinary future annuity. Now we presume normally payments are made at the end of the period. If you are telling us to pay you 10%, not pay you at the beginning of the month. Most companies pay at the end of the month, right? Okay. So we are believing that if they don't specify, if they don't specify the question at the beginning of the period, then we are presuming that it's made at the end of the period, but that's the normal thing. Normal. That is what happening, right? So let's look at this formula. Let's pay attention to this formula. I start something. Why this formula is like this? It is an equal amount of payment. Now, this payment, they are saying they are going to make payment. Let's say 3. It can be more. So equal amount of payment. Okay? Now, one thing we know that the first payment made is what? The time you is end the time, right? I used to the but I end the time. So this time, there's a certain line of this. But if I tell you that I'm going to give you one for 4 years of the year, now if I give you, if I say I'm investing it for 4 years, that is 4 years, right? 4 years, and I'll pay at the end of the period. So if the first year I pay it in December, why it will not be on the end? It's because the first period is already gone. So you are not going to get interest on the first period, but you will pay at the end of the period. So you will be bringing -1, meaning that if the years spend amount of interest, guess what? The next one is going to also be -2, and it was at the end of the period. And this one, the first year I do pay the beginning when I pay it, I pay I don't want to get from it. I will try to get from it from 10 people. That's some target here. This look at the picture. The same amount I paid, the year amount I paid, minus 3. The first 3 years, this amount was not there. The 10 years I paid, so how do I get it? So that's how come you have what? Power 0. But this is equal amount, so we have a simplified formula for it. We are calculating what? Future value, future value. If there's a level of what? Compounding. So look at this formula. We have payments. The next amount of payment, then this annuity formula, right? So there is some compounding formula in it here. Present value and future value. Now, not that if we have a present value, there will be a discounting factor in the formula of annuity. Future value will be a compounding formula in the annuity formula. Okay, so this is the formula, right? This we are going to use this formula. Okay, so let's move on. Let's read this question. If you deposit 100 cedi at the end of year for 3 years, each year, so there is 6 of equal payment year for 3 years, all the quantity of annuity and equal amount, equal amount, and specified period into a savings account that pays 5% okay, so we take the formula. Let's identify the information. Okay, they say they want future value, right, of this amount. Now, this amount, this amount is the present value of entity. So we want to know at the end of the 3 years, what are we getting? So now we have the regular payment. They are saying the regular payment, which is the M, is what? 100 cedi. Okay, then we have what? The rate, right? Rate. So the interest is what? 5%. 5%. I say we don't use percentile here. We don't use percentile here, so we just make it out. We just make it okay. So this will be 0.05. I don't know why it's not coming, but zero point 5% is 0.05. Then we have the time. They said what? 3 years. So time is what? 3. Now let's insert the information into this. So future value is equal to payment into bracket 1 plus this 1, please, plus R. I'm trying to let you go there. That's why I'm squeezing. Right? This is the power T. So please, the N is, this is N. And N. raised to the power n minus 1 and all over. Okay, so are we okay? So now let's solve for the question. We are looking for future value, okay? They say the payment is what? Regular payment is 100 cedis. So we write down 100 cedis. Open our bracket. We have 1 plus, the rate is what? 0.05. So 0.05. Raise the power what? N is what? 3. Raise the power 3. I hope you can see the 3. Minus 1 all over the rate, which is 0.0. I think I should just be free. So, okay, so we continue with the calculation. We have 100. Okay. 1. Sorry. All right, so we have 1.05 raised the power 3 minus 1 all over 0.05. In order to be fast, right, we are going to, in every don't jump steps, but we don't know which step we are trying to last. So I just want us to finish with this fast because when the video is long sometimes. So we have what? 1.05 raised to the power 3. Okay. Now I want to subtract the 1 from it and 1.05 raised to the power 3. Please. I want to subtract this 1 from it so that we finish early. So minus 1. Okay. Sorry. 1.05 raised to the power 3. We get the answer minus 1. We are getting 0.1 5 7 6 all over 0.05. Okay, bear with me. Okay, so that will be equals to, that's why I like to see that so that when we are writing on that, that will be equal to 100 times. So we have what? 0.1576 divided by 0.05. We have what? 3 point, point out to make it 3.152. Okay. So, all right, so that will be 100 times 3.152. And we are getting what? 315.2. So 315.2 Ghana cedi. To mean that this 100 you are going to save for 3 months at this rate, sorry, save for 3 years at this rate, you are going to get 350 50 pesos at the end of what? 3 years. Okay. All right. So that is it. Please, if you have any question, put it on the comment section. All right. Now we are at annuity what? Due. The future value of annuity due. Future value annuity, right? Meaning that yes, we are determining the future amount of a current series of amount we'll be paying, equal amount we'll be paying, but this payment is made at the beginning of the year. Now let's pay attention. The difference in formula. You could see that when this amount, the future value was being paid at the end of the year, which is ordinary annuity. This was n minus 1. But this one is at the beginning of the year. So if I'm paying amount for 4 years, right? 4 years. The first amount I'll be paying yearly. Meaning that the first amount I will need that was and because it was paid at the beginning of the year. So that first year she was how much interest. All right. The second year payment I'll make to take what the first year for me because the first year was not there. So the second amount I'll pay will attract 84. So if this 4 years attracting for 4 years, this is attracting interest for 6. This will be attracting interest for the third amount will be attracting for 2. Then the last amount I'll pay because it's paid at the beginning of the year. I will get the amount of the what is the same annuity formula plus additional what? Compounding what? Plus additional compounding formula. This compounding is what? I think this year, because I paid at the beginning of the year, that year, because this formula, it doesn't include the first year. So we add it to it, you know. So that would be it. So let's solve a question. Let's solve a question at the beginning of the year. All right. I think should I solve? No. I'll use this to explain to you, right? So if you deposit 100 CD at the beginning of each year for 3 years, so the same question like what? The one I solved for the first one, the one I just finished solving, right? But this one is what at the beginning, and that one is at the what? End of the year. Okay, so at the beginning for 3 years in a savings account for that pays 5% interest per year. How much will you have at the end? So note, the only difference between this and the previous formula is this. Okay, so I'm taking you through this. The regular payment is what 100 CD. The number of period is 3 years. The rate of payment is what 5. Now the only thing we don't have is the so we just insert them into it, right? So regular amount, yeah. The rate is inserted here. We have what 3 years minus what 1 based on the formula all over what the rate. Then we add the compounding formula to it 1 plus what 0.05. So that's it. So when you calculate all this, you get this. This you get what this. Okay. All right. So now let's go to present value annuity. Present value annuity. Now, present value annuity is when present value annuity is when we want to determine if they promise you regular payments, equal payment for a specified time, and you want to know the current value of that amount, then you use present value. And that one we have present value of annuity and present value annuity. Where present value of annuity is payment at the end of the period, and present value payment at the end. This one, see, So I make payment at the end of the period. This is annuity, ordinary annuity. Yeah, at the end of it, so this formula, the discounting factor, right? But then we can, since it's a regular amount, yeah, I can use the annuity discounting formula, right? So that is it. Okay. Now we are going to solve question. I think the first one, I solved the ordinary annuity for future value. So this one I will solve. Let me see. Whether we have question on that one. Okay. Okay, you have question here. All right. So this one is saying what? Present value of what? Series of payments. There's a formula. Now this one I'm not solve. I will solve the one with annuity due. Right? That's what I need to do. Okay. You just have to save some time. So let's identify the information. The present value is a formula. Payments, we have 1 minus 1 over the discounting factor, right? 1 plus r raised to the power n and the rates. Okay. Now let's see something. So let's identify. Regular payment is what? Is it Mr. Neiman has won a scholarship which pays him 5,000 per year for 3 years, right? 3 years. So there's a regular payment, which is 5,000, and it has been inserted here accordingly. Now we have the 3 years, so that is where the n is. N is the time, so number of periods, then the discounting rate is what? 7%. This is 0.07. Okay, so that is what it is stated here. Okay, then over this. Now when you calculate all this, you get this. Okay, so now let's see. They promise you what? 5,000. Now ordinarily, if you are to say you want to do this without taking time value of amount was this, you would have just said now you'll be getting 5,000 times what? Which would be what? 15,000. And this is what would have come to your mind, right? All other things, that was 15,000. Okay, so that is it. 15,000. But you see that when you brought it to the present value, this is it. So this 15,000 will give it to you. You will be getting whereby for the 3 years. That's the actual value as it stands now. Okay. All right. So let's go to present value. Present value and it. Okay. This one, they are saying they are going to pay regular amounts at the beginning of the period, a future amount at the beginning of the period. Every January, and I'm just using here. So every January, they're going to pay this amount for some time, for a specified time. Okay. So there's the formula. And see the same formula that they've added what? That's beginning of the year. They've added it to it. Okay. So I'll be solving this with you. Okay, all right. So let's identify the information. Let Mr. Carl will receive 8,500 per year for the next 15 years from her trust. If a 7% interest is applied, what is the current value of the future payment if first receipt occurs today? Okay. So now let's see. So it means that the regular payment is 8,500. Okay. Now the time period, this we are using n. Is n. The number of period is what? 15 years. All right, then we have what? The rate. The rate is what? 7%. And that will be 0.07. At this level, I don't need to explain further. It's how you got this. It should know. I think we have everything we need, right? Regular payment, rates, time. Okay. So now let's now put in the formula. We have present value is equals to payment I'm solving with the due. Payment into bracket 1 minus the discounted factor 1 plus r raised to the power what? N bracket close all over what? R. Okay, times what? 1 plus R. Are we okay? Okay, so let's now look for present value. Regular payment is what? 8,500. Bracket open. We have 1 minus 1 over, don't get, okay, 1 plus 0 point okay, 0.07 bracket close. Raise the power n is what? See, 1, 5. All over 0.07. I don't know where this. Okay. Then we have 1 plus 0.07 bracket close. So let's do the maths as fast as possible. We have 8, 5. We have 1 minus 1 over. Let's do the 1 plus 0.07 will be 1.07 raised to the power 50. So let's do that so that we finish solving the question. So that will be what? 1.07 raised to the power 15. So that will be that. This all of this will give us 2.7 7, 5, 9, 0. Okay, all over point 7 times 1.07. All right. All right, so you are continuing. All right. 8,500 1 minus 1 divided by. So we are doing this, okay? This 1 divided by 2.7590. We are getting 0.3 plus 25. Okay, all over 0.7.